Good morning, everyone. How are you? That good, huh? I'm pretty good. Oh, and yes, Alyssa, yes, you can. It is We Share Wednesday, so if anybody wants to share, you can. Jessica, that's so exciting. I think she's probably hoping for a baby. I'm putting it out there. I'm guessing that's what she thinks it is. Not a puppy or anything like an otter, anything like that, right? I didn't find out with any of mine. All four were surprises. Isn't that exciting? Here's why. Because if I knew what I was having, I'm not sure I would have made it through the pregnancy. I would have been like, that's like the best Christmas gift ever, and you can't open it for like however long, right? And it's not like I had 30 options. It was just a boy or a girl. So I thought, how many surprises like this am I going to have in my life? Not many, right? Just four. So, and it was so funny because my mom had all girls, and when my oldest was born and it was boy, um, I called my mom on the phone and I said, "Mom, it's a boy." Like literally, Mom, it's a boy, and she's like, "Really?" I was like, "Wait a minute. Did did you think I was joking?" Yeah, it really is a boy. And she was like, "Oh, I'm just shocked." I was like, "You are a weirdo," because like that was so out of the realm of possibilities. Literally, there were two choices, right? So funny. All right. Yeah, so it's hard to find out or to not find out. So I told you the twin boys, she didn't know she was having boys. And they had those twin boys, and they're home, by the way, and they're great and no problem. And then my niece in Hawaii knows she's having a girl, and then we're having another one in December, but we don't know if that's a boy or a girl. So pretty fun. My parents have six grandsons so far, but the granddaughter is on its way. So, all right. And I saw some other things. Somebody's getting their nails done. And Cameron, we can see it. Nice. What made you go so dark?
I
And
have
somebody else is getting a new PC too. Go ahead, Cameron. I'm ready.
I have no I guess I really had no reason why I wanted it like really dark, but like I always like thought what I would look like a different color. This is the first time I ever dyed my hair, so
And are you happy with it?
hmm
Nice. That's awesome. All right. Ooh, nice. Um, Alyssa's getting a new PC. That's awesome. Um, Gabby Hanna posted a lyric video yesterday that Jerice animated. I'm so excited. Good job, guys. I love your news. Oh, Haley, what color? A light red. Okay, yeah, that makes sense. So nice. That's awesome. What was I gonna say? I don't even know. Oh, it's We Share Wednesday, and that's why we're all sharing, but it's also We Care Wednesday. And remember at MCC, you can pick up your food distribution box today. So if that's you or you know somebody who wants to go get it, remember they do have drive up options available. Okay. Oh, yeah, blue. I think those really bright colors fade really quickly. Yeah. So if you don't like light, then you'd have a problem. All right. So any other news? No? Yes, maybe. Okay, I'm a little annoyed my computer is not being cooperative today, but it's okay. I mean, we'll make it through. Oh, maybe it's more cooperative than I think. Maybe it's just me. Yeah, that's weird. It's okay. It's all good. It's really there. I feel better. Okay. Yesterday you played your game and you guys did awesome, and I have some data to share with you. So what we're going to do first, before I share our data, we're going to compute some theoretical probabilities. So, and let me get to where I need to be. One moment. Okay. I'm going to share my screen and, okay, maybe I won't share my screen. We'll see. Maybe we'll just try it this way. See if he gets mad at me. Okay. We'll see. If this doesn't work, I'll have to join on my iPad, but we'll see. Maybe it'll work. Please work. There we go. All right. So we share theoretical probability. I'm going to put a document in the, actually I put it right here. So this is what I want us to look at right now. So, and I can put this in the chat if you would like it in the chat. Let me find it and put it in the chat if some of you like to follow along. Yeah, everything's gone from the chat. That's sad. I don't know why. One moment. Okay, here it is. I will share this doc with you. So in case you want this to help you follow along, wish I could find all the stuff on my screen. Chat, there we go. Okay. So today we're going to talk about the difference between theoretical and experimental probability. So yesterday you played a game which would be gathering experimental probability, getting that data. I do not know why this is in the way, but I think you can see my whole screen, so that's good. So this chart that I have up on the screen is theoretical probability. So here are our options. So do you see how it says the sum of two dice? So you're going to fill this out kind of like a probability, I mean like a multiplication table, but now you're just adding. So for this box right here, I would say 1 plus 1, and I'm going to write 2. Then the next one, 1 plus 2 is 3, and then 4, 5, 6, 7. Everybody see what I'm doing here on the screen? You okay? All right, and then we can keep going, right? 2 plus 1 is 3. This would be 4, 5, 6, 7, 8. What this is doing is listing all our possibilities, right, of our dice. So we could have the first dice be a 3 and the second dice be a 1. That would give us 4, 5, 6, 7, 8, and 9. And then 5, 6, 7, 8, 9, and 10. 6, 7, 8, 9, 10, and 11. And then 7, 8, 9, 10, 11, and 12. So what I want you to do right now is I want you to count up things and see if this makes sense to you when you say, okay, how many possible outcomes were there of the item that we're talking about? So for example, how many ways could we get a 1? Well, notice there's no 1 on this whole chart. So that's going to be a 0. How many ways could we make a 2? Well, there's only 1, 2, and it's right there. So that's going to be a 1. How many ways can we make a 3? That's a 2. And go on all the way down till how many ways we can make a 12 with our dice. So figure those all out, and then we'll figure out the total number that's possible. All right, did you figure out all those? All right, so what would I write across this? After I wrote 0, 1, 2, what would I write under 4?
3.
Mason, well, there you go. Thanks. Somebody, I don't know who that was, but perfect. Thank you. Keep going all the way across. Somebody else tell me. It's going to be a long day if you guys don't talk. Mason, go ahead. What would I write in that next box under 5?
Under 5, I put 4.
Very nice. And then under 6, Antoinette, what would I put? Very nice, Caden. Thank you. 5. And then keep going. Thank you, Haley. And Frida, good job. And then the next one, it starts going down. It goes 5, and then it's going to keep going down. 4, 3, 2, 1. Anybody have questions on where I got those numbers? Everybody all right? It's how many outcomes that have that sum. So if you look at your picture, right? If you look at your picture right here, for example, 7s, they're right here. There's 6 different ways to make a 7. So that's why I wrote a 6 right there. And then how many total possible outcomes are there? Like out of this whole chart, what number of total outcomes do I have?
Would you have 36?
Very nice, Cameron. How'd you get 36?
By adding all the total numbers like on the top row, I added all those together. Or wait, hold on.
Just 6 by 6?
Yes.
There you go. This is a 6 by 6 grid, so there's a total of 36 possibilities. So when you find probability, you can report it as a fraction, or you can report it as a decimal, or you can report it as a percent. So what I want you to do right now is figure out the percent of each one of these. This one is really easy. This is going to be 0 out of 36, right? So that's going to be 0%. And then figure out what 2, 3, 4, and all the way up to 12 is. So I'm going to slide back a second so you can see. You're going to calculate the percentage for rolling all the sums. And it says round to the nearest tenth. So that's what I want you to do, round to the nearest tenth for all of these. And make sure you're coming to class, so you should have either a device that you're writing on, or you should have a paper and a pencil that you're recording all your information on, right? So then when I ask you for the answers in just a minute, you have them. Okay? Sound good? All right, so I'll give you about a minute to do all those percentages, and you're rounding to the nearest tenth. All right, so did you finish all those percentages? Whoops, sorry, I don't know why it flipped upside down. That was very fun. Okay, so tell me what percent you got for 2.
5.6.
5.6%. Excellent. Wait, yeah, so that was for 2. Excellent. What did you get? No, that was for 3, right? For 2, it was 2.8%.
Oh, yeah. Sorry, I read the wrong.
Okay.
Yeah, it was 2.8. Okay.
Okay, good. And then so for 3, it's 5.6%. What was it for 4? Haley, what'd you get for 4?
I got 8.3%.
Is that what everybody got? 8.3%?
Yep.
And for 5, Morgan, what'd you get? Oh, you're still muted.
I didn't do that one.
Okay, so do it right now. You have your calculator right next to you. Just do 4 divided by 36.
Um, 11%.
And if we rounded to the nearest tenth, what would you say?
Like 0.1.
There you go. Perfect. 11.1%. Brianna, what'd you get for 6?
13.9%.
Excellent. Perfect. 13.9%. For 7, Derek, what'd you get?
16.7%.
Sorry, say it again.
16.7%.
Perfect. 16.7%. And then, did anyone notice what happened when you did the ones on this side, when you went back down 5, 4, 3, 2, 1? Because you shouldn't have to calculate those again, right?
They're the same as the other side.
Right, they're the same as the other side. That's perfect. So this should be a 16. Sorry about that. And then 13.9%. And then we're going to keep going down, right? So 11.1%. Any questions on how we're getting those percentages? Okay, because you're going to do more in just a minute. So what I want to show you now is, hold on. This is what that looks like in a picture. Okay, so if you look on this side over here, we have our fractions, right? So 1/6, that's 6 out of 36. That's the same. Notice right here, it's our 7s, right? Those are all the ways to make a 7. And that had the highest percentage. It was over 16%, right? Okay. And then notice that it goes down on both sides. Do you see how this is a symmetric distribution? Just like we learned in statistics. So this is a symmetric distribution. It is connected to statistics. This was our theoretical probability just in a graph. Now I'm going to show you, we're going to compare our experimental data that we got yesterday. Oh, I forgot I can't touch that. Hold on. Maybe it's this one. Let's take a look. Nope. I don't even know where that went now. That was scary. Okay. So these were all those results that you just got. Okay. Now this is the data we got from our class, and this was all our classes together. Okay, so remember I had 5 different classes that were putting data in here. So we had a total number of roles of 3,850 roles. Okay, and then these were our outcomes. So what I did was I took that spreadsheet you guys entered into, and I calculated, I summed all those things right there. So what I want to do now is I want you to calculate your percentages of your experimental data, and we're going to compare it to our theoretical data that we just figured out, okay? Now I just have to find my Zoom thing so I can put your stuff in the chat. Oh, it's crazy town today. Okay, I only have about 50 windows open on my screen, so that could be the problem. So there's the doc for you, okay, that has all these numbers in it. So you don't need to copy it if you don't want, but I need you to calculate all these percentages. And after you calculate these percentages, we're going to talk about the comparison between them, okay? All right, so I'll give you about, I don't know, 2 minutes to calculate all those percentages. So try that. So you're going to do the same thing. So our procedure is going to be to take the number of rolls and divide it by the total rolls. So to calculate this percentage, I would write 0 divided by 3,850, and I would get 0% there. So calculate all those and then we'll compare. And if you have a question, you can chat to me while I give you this time, because I'm just going to call on you guys randomly. All right, how'd you do? Did you get them all done? Almost all, I hope. Okay, so I'll do the first one. That was the easy one. That's 0%, right? Okay, how about for the second one, when you did 144 divided by 3850, and then you multiplied by 100 to make it a decimal, and you rounded to the nearest tenth. So Cheyenne, what'd you get for that one?
I think I did it wrong, but I got 0.37.
Okay, so that's the 0.037 is the decimal. Now, when you multiply it by 100, it'll be 3.7%.
Oh, okay.
Does that make sense?
Yeah.
Okay. So now, Nathan, what'd you get for the next one?
I got 6.2%.
And if you guys get a different answer, make sure you tell me. Okay, and then for 4, Yamalis, what'd you get?
I got 8.5.
8.5, is that what you said?
Yeah.
Just making sure. Is that what everybody else got? Okay, and then for 5, Jessica, what'd you get?
11.4%.
11, oops, I don't know why that went way over there. 11.4%. It doesn't want me to write any more right there. Okay, and then for 6, Caden, what'd you get?
I got, which one were we at? 6?
For 6, yeah.
I had 13.8%.
Very nice. That's what I got, 13.8%. Excellent. Any questions on where we're getting these numbers? You okay? Gino, what'd you get for the next one? And if you guys can't talk, like, because you're muted or whatever, you can just type it on the chat.
Got 16.4%.
Okay, I don't even know where I'm typing now. There we go, 16.4%. And then for 8, Rocky, what'd you get?
I got 12.6.
Very nice,
Or do I round it to
12.6%.
the 7?
Yeah.
6.
Melanie, what'd you get for that one? The next one, 9?
I got 11.4.
Okay. And then for 10, Jerice, what'd you get?
Sorry. I got 8.2%.
Okay. Oops, I don't know why it's not letting me type over there. There we go. And for 11, Melissa, what'd you get?
Got 5.5%.
5.5%. Excellent. And JLo, what'd you get for 12?
I got 3.1%.
Did you say 3.1?
Yeah.
Perfect. Excellent. Okay, so now that was a reminder of how to calculate percentages and everything like that. I don't know why that went way down there. There we go. Okay, so what I want you guys to think about right now, and I'm gonna give you about 15 seconds to think. I want you to compare these numbers right here in this bottom row for our theoretical data compared to our experimental data, okay? And think about, are they close? Are they not very close? Is there one that's really close and then others that are far away? What do you think? So think about it for about 15 seconds, get it ready in the chat, and I'm gonna have you type it in the chat in just about 15 seconds. All right, everybody ready? In 3, 2, 1. Yeah, so very nice. Most people are saying it is really close, right? They're only about maybe 0.2 percentage places off, right, on a lot of them. What do you do notice? It would still approximate that symmetric distribution. Notice that 7 is still our highest value, right? And then it tapers off on both the ends. Laura said, is it a normal distribution? Well, for it to be normal, we would have to say the mean, median, and mode are all equal to each other. So we would have to test that out, but it is definitely a bell shape, right, in this curve. So you can see it. So what I wanted to show you was I didn't make that data up. You guys generated that data in my other classes, and Melina Prewee's other classes generated that data from doing an experiment, right? That's why it's called experimental probability. But this theoretical probability, we didn't need to calculate using any experiment. That was just what we know about dice rolls. So our experimental data will approximate our theoretical data if we do a lot of trials, right? If we would have just taken your teams, like one partner pair, and compared it, it might not have been close at all. But if we keep doing the experiment a lot of times, then we get closer to this theoretical data. And if we did this again and added all those extra experiments, like instead of doing 3,850 rolls, if we did 10,000 rolls, we would get even closer to our theoretical data. So this is fascinating to me because this is how statistics came about, right? They noticed that they could kind of predict what would happen in an experiment because they could figure out in theory what should happen. It doesn't always work, but if you do an experiment that's large enough, it will approximate that, okay? So do you understand the difference between theoretical probability and experimental probability? Okay, excellent. Good job. Now, let me get back here. So we're going to do a couple examples, and we're just going to do these in 3, 2, 1 chat. So our exit ticket yesterday was about rolling a dice. Do you remember that? And it was about if you roll one single-sided dice, I should clear all those drawings. Okay, so if the exit ticket was the probability if you roll, I think it was a 4 on a single-sided, a 6-sided dice. So, and how we figure out probability is we say, okay, how many 4s are on the dice? Because those would be successes. And there's 1 4. Remember, we're only doing 1 dice. And then how many total numbers are on the dice? There's 6. So the probability of rolling a 4 on a single 6-sided die would be 1 out of 6. And some of you got it right, and some of you didn't. But if you think of probability as success to total, that will really help you find the answer. So how many successes are there, and then how many total are there? So when you're doing this one, again, we're rolling a 6-sided die. Figure out the probability of rolling a number bigger than 2. So not 2, but bigger than 2. So calculate that, okay? You can just write it as a fraction. You don't have to do a decimal or a percent, just write it as a fraction. Okay, get it ready in the chat. All right, and 3, 2, 1, go. All right. So I saw some 4/6, I saw some 2/3, I saw some 66.7%. Those are all correct. So if we think about it, if it's a number bigger than 2 on a single-sided dice, that's going to be a 3, 4, 5, or 6. So there are 4 successes or possibilities out of a total of there's 6 numbers on the dice. So 4 out of 6 is correct. If it says it needs a simplified fraction, which is what more will ask for, then you simplify that to 2/3. If it asks you for a percent or a decimal, you just need to make sure you follow those rounding rules. Any questions on that one? All right. Then try this next one and get ready in the chat. Compute the probability. You're still tossing just one 6-sided die, and now you're going to get a 7. What's the probability you're going to get a 7? So think about it. Get it ready in the chat. All right, and 3, 2, 1, go. Nice. Look at all those. So 0% or 0. Some people put 0 over 6, which is totally true because there's no way to get a 7 on a single 6-sided dice. But once you simplify that fraction, 0 divided by 6, you're going to get a 0, right? Okay, excellent. So, because this would be 0 out of 6, which would be 0. And there's my answers right there. Okay, I gave you fraction, decimal, percent. Now, this one's a little bit trickier because we first need to make sure we understand the difference between a vowel and a consonant. Can anyone explain that? Some of you are English majors or writing majors. You might know it a little more than somebody else.
Vowels are A, E, I, O, U, and consonants are every other letter.
Okay, perfect. So A, E, I, O, U are vowels, and a consonant would be everything else. So get those ready. Yeah, with sometimes Y, we're going to pretend Y is only a consonant for now, okay, just for the sake of this problem. Okay, so we're either going to say it's a vowel or a consonant. Okay, so this says you write out each letter of the alphabet on a different slip of paper and put the slips into a hat. What's the probability of drawing one slip of paper from the hat at random and getting a vowel or getting a consonant? Okay, so how many letters are in the alphabet? Does anyone know?
Aren't there 28?
There's 26.
26.
Yeah,
Okay.
there's
I was
26. So that'll make a difference in your probability. So calculate your probabilities on both of those, and then we'll just check them. We don't have to do a 3, 2, 1. We'll just check them in a minute. Nice. You guys are all over it. Good job. So the 5 out of 26, it's 5 letters, 5 vowels out of 26 total. I love it how some of you guys are doing percentages. That's perfect. So I just did the fraction, so 5 out of 26, and then 21 out of 26. Any questions on where those came from, or anyone need help with that? All right. So the math isn't that difficult, I don't think, in your whatever it's called in this unit. I don't think the math is the hard part. I think the understanding is the hard part, making sure you know, oh, how many letters are in the alphabet, those kind of things. So try this problem right here. A white ball is drawn randomly from a jar that contains 6 red balls, 2 white balls, and 5 yellow balls. Find the probability of the given event. Now, if you remember your partner from yesterday and they're here, I want you to chat to your partner, okay? And if you remember, if you are an A or a B, I want A's to chat to B's, okay? So for example, I know Haley and Joya were partners. I don't know who's an A and who's a B, but one of you chat to the other person when you solve just the first part of the problem. So where it says, what's the probability a red ball is drawn? Okay. And if your partner's not here, you can't find them on the participants list, chat me privately. Okay, now the partner who just got a message, Antoinette, you were partners with Mariella and she's not here, so you can chat to me. The person who just received a message is going to chat to everyone in the 321 chat, okay? So, and Antoinette, you can just chat to everyone, okay? So 3, 2, 1, go. I got Cadence, that's it. Where'd everybody else go? Did nobody else get a message? Oh, there we go. Okay, I feel better. You guys are rock stars. I think some of you were answering the second part. All right, so 6 out of 13 is correct for the red ball is drawn. So how about someone explains where they got that 6 out of 13?
You
I
add up all
can't.
the numbers and then you just take what the red ball's amount is and then divide it by the numbers.
Okay, so you added 6 plus 2 plus 5, which is the total number of balls in, or marbles. Is it balls, marbles? I don't know. Sometimes they say marbles. So in a jar. And then there's a red ball is drawn. So there's 6 red. So we go 6 over 13. We could give that answer as a decimal, so 4 decimal places, which would be 4,615. And we could give it as a percent if we were rounding to the nearest tenth. We would do that. Okay, and then some of you gave me the answer for a white ball being drawn, which is great. Okay, this time the white, there's only 2 of them, so you're going to do 2 over 13. If you give the decimal to 4 decimal places, it would be 0.1538. And then if you round it to the nearest tenth, you would say 15.4%. Now, let's do this one right here. Compute the probability of rolling a 12-sided die. That means it's numbered 1 through 12, right? All the way up to 12. It has 12 sides. By the way, that does exist. I don't know any of you who are gamers, like board gamers or D&D or anything like that, but they do have multi-sided dies. There's 20-sided dies and so on. So compute the probability of getting a number other than 8. Any other number other than 8. And this time, get it ready in the chat. Don't hit enter yet. And you can give it to me as a fraction or a decimal or a percent. All right, 3, 2, 1, go. Very nice. Excellent. Okay, so I think you guys are getting the idea of how you find probabilities on these kind of things. Any questions on these? Okay. So how many of you know decks of cards? Because you play card games. Anyone? Anyone know decks of cards? Okay, some of you do. Now, Mason says, of course, but you have to be careful. There's a lot of people who don't know decks of cards because they didn't play cards growing up. It's true. I'm shocked. I know it's sad. I love playing cards. So in our in your materials that you'll have this module, you will have a handout that has a deck of cards on it like this, and you will be able to use it on the test as well, because I don't want that to hold you back from understanding. So this is what a standard deck of cards looks like. Does anyone know how many cards are in a deck? Haley, go.
52.
Very nice. There's 52 cards in a deck. So, and there's 4 suits, and you can see them here. The suits are across, okay? So there's 13 cards in each suit. And the suits are spades, hearts, diamonds, and clubs. Most people are okay identifying a heart and a diamond, but not everybody knows that this is a spade. It's supposed to resemble a shovel. A shovel is called a spade. So that's where that symbol comes from. And this is a club. So this one is a club. This one is a spade. The club kind of looks like a clover, okay? Half of the cards are black, half of the cards are red. So there's 26 red cards and there's 26 black cards, okay? And each suit has ace through king. For some of you are like, seriously, we have to explain this? Yes, we do, because it's important. And then over here, these are face cards. So jacks, queens, and kings are face cards. Aces do not have faces, so they're not face cards. Don't confuse that, okay? All right, so knowing that, let's try to figure out this. If you pick one card at random from a standard deck of cards, what's the probability it's a king? That's one problem. What's the probability it's a diamond? And then what's the probability it's a face card? So try that. Try all those 3. You don't have to get them ready in the chat. I'll just call on somebody in about 1 minute. All right. So let's see how you do with these 3. If you didn't finish them all, it's okay. So for a king, the probability it's a king. Mason, what'd you get?
1 out of 13.
Excellent, because you really got 4 out of 52, which simplifies to 1 out of 13, right?
Right.
Excellent, that's perfect. And then if you got the decimal, it would be something like this, or the percent. How about a diamond? The probability of getting a diamond. Corinne, what'd you get?
I got 8 out of 52, or is it just 4?
Oh, good question. Let's go back and look at our picture. So diamonds, there's all of these. So we're going to count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's actually 13 out of 52. But it's okay as long as you knew that you had that handout for you, which really simplifies to 1 out of 4, which is 0.25 or 25%. Okay? Excellent. And then a face card, I'm just going to show you the answer on that one. Should have been 12 out of 52, which simplifies to 3 over 13, and those decimals and percent. Now, we have a lot more practice we're going to do tomorrow. I'm going to show you this right now. We are not doing a mini lesson for homework tonight. It'll be for tomorrow night. You are doing this for homework tonight, okay? So make sure you know that you just have your more practice for tonight. There's your exit ticket. And you guys did awesome today. I'm hoping we can get in your groups tomorrow because you're going to work on some practice and some team problems. Our 50 minutes goes super fast. So good. If you have any questions, stay on here and I can answer them. Otherwise, make sure you do your exit ticket.
The exit ticket says I already responded.
Oh, well, that's stupid. Hold on. I must have put a wrong link in there. Oh, I did. Hold on one moment. The QR code was probably wrong too. Oh my gosh, my whole screen
No,
just went crazy.
the QR code is right. I did it.
This is a sign that we don't want to do our exit ticket. Am I right?
The QR code was right though.
Oh, the QR code was
Yeah.
right. That's even scarier.
Yeah.
That's even worse. Okay, so the QR code was right, but this link was wrong. So this link must be right. Try that one. I guess it pays to use the QR code, huh?
That's what I always do.
I must have just put the wrong one in there because the screen was right. All right, I will see you tomorrow. Thank you. I'll put up the QR code again too.